everyone, in this video we're going to sketch the graph of exponential function with transformation. With transformation means that the equation that we're going to use would be y equals ab raised to the power x minus h plus k. So this is the general equation and this is the second part. I will put the link of the first part in the description box below. Before we jump into this first example that we have here, we remember that there are some steps that we need to follow in order that we can sketch this type of equation or exponential equation. The first step is to determine the locator point and the asymptote and sketch the graph. So in this problem that we have here, I'm just gonna go ahead and label this as S1. So we remember that the asymptote for this exponential function of this general form that involves transformation is that the asymptote is equal to y equals k. So pretty much our k here is -4. That matches up to the k. So then we can go ahead and label the asymptote here as y is equal to -4. Okay, part of this step is to determine the locator point. So the locator point is the HK, but we need to label that right here. So locator point would be, we remember that we are supposed to switch and keep since this is a -1. So I go ahead and write 1. And then keep the sign of the -4. So I go 1 and -4 is our locator point. So then we go ahead and sketch these two, asymptote and locator point, in the graph here. So we start with the asymptote, which is y is equal to -4. And then our locator point is located at 1, -4. So I go 1 and then -4. I am using pencil for this because locator point is not part of the graph. This is a point that determines where to go, up, down, left, or right. So I use pencil because we're going to erase it after we're done drawing the graph. Now we're ready to move on to the second step. The second step is to determine the equation and complete the table. So in order that we can determine the equation, we covered, just like what we did with the rest of the equations, we're supposed to cover the h and we're supposed to cover the k. Whatever is the leftover, that's the equation that we're going to use in the second step. So in this second step right here, the leftover equation would be y is equal to 2 parentheses 3 raised to the power x. So this will be the equation that we're going to use in order that we can complete the table down here. So from the locator point, I've completed the table. Our next task is to determine what to write on these boxes right here. So again, our equation is 2 parentheses 3 raised to the power x, and these are the x's that we put in there so we can solve for y. So in this problem right here, I can go ahead and write 2, and then that's 3 raised to the power. The exponent x is -1. And then again, we remember that when we have a fraction with a negative exponent, in order that we can make the fraction or the exponent positive, we have to flip the fraction and the exponent becomes positive. So remember that in this problem right here, the 3 has an invisible denominator of 1. So then I can go ahead and rewrite this as 2. That's gonna be parentheses, flip it 1/3. And the exponent now becomes a +1 because I flipped it and the exponent becomes positive. So in this case right here, we can go ahead and simplify this as 2 parentheses 1 to the first power is just 1, and then 3 to the first power is just 3. So 2 times 1 is 2, and that's over 3. So pretty much if we change this into decimal, 2 divided by 3 is 0.67. So that's 0.67. Now we're ready to move on to the rest of this. I'm just going to show the work right here. since all of these are positive, we can go ahead and say that these ones are going up. So all these three are going up. So pretty much what we do is from the locator point, we are going to go 1 to the left and then 0.67 up. So I'm gonna go 0.67 should be more than half, a little more than half. So 0.67 is right here. So again, what I did was I went 1 to the left and 0.67 up. The next dot is 0, so that means I'm not moving anywhere, but I go up 2. So 1 and 2, so this is the next dot. And then from the locator point, I go 1 to the right and then 6 up. So it's going to be 1 to the right and go up 6. 1, 2, 3, 4, 5, 6. So this is the next dot right here. So then I can go ahead and connect the dots together. So this is the first half, and then this is the other half. Now please remember that the other tail is going to approach towards the asymptote, but it's not going to touch it. So make sure that the graph or this graph right here doesn't touch the asymptote. An asymptote is a line where the graph gets closer and closer to it, but it doesn't really touch it. So this is the graph of this equation right here. On the side, you will see the Desmos version of this graph. So as you can see, both the paper version and the Desmos version are just the same. At this time, I would encourage you to pause this video and try this problem out on your own. And when you're done, unpause it and check your answer. Okay, so we go over the problem here. Again, the first step is to determine the locator point and the asymptote and sketch this on the graph. So I'm just going to write S1 right here. So our asymptote here for this problem that we have right there. So I'm just going to label this. Please remember that the asymptote for exponential function with transformation is that y is equal to k. So our k is a positive 4. So we can go ahead and write y is equal to positive 4 or just 4. Now the locator point is, remember, we are supposed to switch and keep. So that would be a -1 and a positive 4. Now we're ready to sketch both the asymptote and the locator point. So the asymptote is located on y is equal to 4. So it's going to be up here. Okay, so the next thing that we're going to do is to move on to the second step. In the second step, we're supposed to determine the equation and complete the table. So in order that we can determine the equation, we're supposed to cover the h and we're supposed to cover the k, and whatever is the leftover, that's the working equation that we're going to use for the second step. So that would be y is equal to -3 parentheses 1/2 raised to the power x. So this would be the equation that we're going to use for the second step. So from the locator point, okay, so I've filled in the table. Now we're ready to fill these boxes in. So again, we're going to use this equation right here. So this will be the x, that's the number that we put in there. So we can go ahead and write this as -3 and then parentheses, that's 1/2 raised to the power. The exponent is -1, which is the x. So I put -1 right there. And again, we remember the property of exponent that whenever we get a fraction with a negative exponent, to make the exponent positive, we flip the fraction. So in this case right here, this 1/2 will get flipped. So this would come out -3, and then that's gonna be 2/1. This time around, the exponent is 1. So anything raised to the power 1 is the same number. So we can go ahead and say that's -3 times 2. So that gives us a 6. So it becomes a 2 because 2 raised to the power 1 is 2. 1 raised to the power 1 is 1. So 2/1 is 2. So that's a -6. So I'm going to write a -6 right there. Now we move on to the next one right here. So it's pretty much the same thing. We just set it up. We just changed the -1 to 0. Okay, so what I did here is anything raised to the power 0 is 1. So negative 3 times 1 is negative 3. And then I do the last row right here. Okay, so what I did was since this is 1 raised, this is already positive, we don't have to switch it. So I'm not switching this because it's already positive. So 1/2 is 0.5. So half of negative 3 would be 1.5, which is negative. Now we're ready to sketch the dots here. So first we remember that we start from the locator point. So from the locator point, I go 1 to the left. So 1 left. And then remember that since these are all negatives, we remember that these are all going down. So this one is going down as well. Same thing for this. So this one's going down. So 1 to the left, and then I go down 6. So 1 left, down 6. 1, 2, 3, 4, 5, 6. So this is where the first dot is going to sit. The next one here is 0, so we're not moving anywhere, but we go down 3. So 1, 2, 3. So this is the next dot right here. And then the next one is 1 right. So 1 to the right, and then we go negative 1.5 down. So that's negative 1, negative 1.5 should be in between this. So that's a negative 1.5. So then we go ahead and connect the dots together. So this is going to go, the other tail is going to go down this way. And then again, remember the other tail is going to approach the asymptote, but it's not going to touch it. So it just gets closer and closer to it, but it's not going to touch it. So this is the graph of this function right here. Now, please remember that the locator point should be erased because again, it's not part of the graph. So this is again the graph of this function right here. On the side, you will see the decimals version of this graph. You can see that both the paper version, the one that we just did, and the decimals version are just the same. Did you get the same answer as this? Good. Perfect. If you find this video helpful, hit like and subscribe for more math videos. See ya!